Calc, let's take a look at a lesson on getting information from graphs and equations. Now, the first thing we're going to do here is take a look at this graph, okay, and take a look at some evaluating. So when it says f of 0, okay, 0 is the input. So 0 is the input, okay, or the x value. So I go to this graph, and when x is 0, okay, that takes me up here to this point. 0 for the x, 4 for the y. So the output, okay, the output here would be 4. This is function notation, okay, input, and they're asking for the output, okay, output, or in other words, the y value. All right, let's do another one. Try to find a point that has 3 pi over 2 for the x value. 3 pi over 2 is the x value, and the y value would be 0. What is f of 3 pi? Yeah, here's the point. You go to 3 pi, that takes us to an output of -4. Okay? When they ask for domain, they are asking for the x values. The x values that this graph is using. Okay, so I'm looking at the x-axis. The graph starts right here, okay, and goes all the way up to right here. Okay, so it starts at 0, and it does touch. When it touches, we're going to use a bracket, and it goes all the way up to a value of 4 pi. Okay, and since it's a closed point, we'll use a bracket. So when you're doing domain, okay, you look left and right along the x-axis. All right, how about range? Okay, when we look at range, okay, now they're asking for what y values. What y values does this graph use? Okay, so now we're going to look how high and how low. We're going to look along the y-axis. Okay, and we're always going to start small. So what's the smallest this graph goes? If using a piece of paper helps, just to kind of let your eyeballs only see certain things, there is no graph down here. Okay, the graph goes as low as -4. -4, and it goes all the way up as high as what? So some people like to kind of go like this and build a wall. Okay, so the range goes as low as -4, and it does touch, so we use a bracket, and it goes all the way up as high as +4. Okay, intercepts are points. Okay, intercepts are points, so we have to make sure we write these in point form. Okay, points where the graph touch either the x or the y-axis. Okay, so first I'll start with the x-axis. Oh, he's got lots of x-intercepts. We've got the point pi over 2, 0. We've got 3 pi over 2, 0. We've got 5 pi over 2, 0. We've got 7 pi over 2, 0. All right, let's not also forget to look at the y-axis. The graph does touch at the point 0, 4. Remember, x-intercepts have x values, and the y-intercept has a y value. Okay, let's keep going. How often does the line y equals 2 intersect the graph? Okay, so when you have y equals 2, if you think back to Vux Hoy, okay, this is a Hoy. This is going to be a horizontal line, y equals 2. I'm going to go ahead and draw this line on the graph. Y equals 2 is going to go right here, y equals 2. Draw a horizontal line. Okay, so this is the line y equals 2. How often does the graph intersect that horizontal line? 1, 2, 3, 4 times. 4 times. Okay, it's really hard to tell where. Okay, I'll just say 4 times. What values of x? Okay. Does f of x equal -4? Okay, you have to make sure that you read this carefully, okay, and that we look at where the value is. Okay, so negative 4 is not the x. That's not an input, okay, that's an output. That's the output, okay, that's the y value. So when we're looking at the graph, we're trying to find y values that are negative 4, points that have something for x and then negative 4 for the y. Okay, let's go take a look at this graph right here. If I look at, oh, here's negative 4. Here's the y value of negative 4, and the graph does touch negative 4 2 times. Okay, for what values of x? Since the question is written like that, I'm going to say when x equals pi and when x equals 3 pi. I'll say the x values. They want to know what x value makes that y value. F of pi made negative 4. Okay. And now for my favorite question. For what values of x does f of x is the graph, okay, where is f of x greater than 0? Greater than 0. So if I go take a look at this graph, okay, I know that he equals 0 right here in these places. He's equal to 0 there, but that's not what it said. It said, where is f of x greater than 0? Where is it greater than 0? So if I look at this graph, okay, maybe I'll just use a little piece of paper. Here's where he's equal to 0, but that's not what it said. It wants greater, okay? So this whole piece of graph right here, this whole piece is greater than 0. That whole piece. I can't just say this point, because look at all these places. Look at all these points. Same thing over here, okay? Is this point greater than 0? Yeah, but this entire piece is greater than 0. And then same thing here. This entire piece is greater than 0. What about those points? Can I equal them? No. That's where it equals 0. Okay, so I'm just going to put like little open bubbles right here, okay? We can't equal these because the direction said greater than 0. Okay, what about that point? That point's greater than 0, so I'm going to use that point. I'm going to make sure that's nice and dark, okay? And so how am I going to say all of this? I can't just say like 4 places. There's infinitely many points all along the way. Point. And so the way that I'm going to say this, okay, for what values of x, I'm going to use some interval notation. Interval notation, okay? When it said greater than 0, okay, this means where is the graph above the x-axis? Okay, and I've got 3 highlighted sections. All right, let's do it one at a time. Okay, this first piece right here, it starts at 0. It goes all the way to pi over 2. Okay, remember, we're looking for x values. So this little piece right here, okay, from here to here, from 0 to pi over 2. Now 0 I like, 0 I can use. The pi over 2, that's an open bubble. Okay, so we're going to start with brackets. From 0 to pi over 2. Okay, open bubbles get parentheses. All right, union. Where's the next piece of graph that's above the x-axis? Oh, this whole piece right here. Okay, from where to where? From where to where? Okay, so this point right here is 3 pi over 2 all the way until I get to 5 pi over 2. Can I equal those points? They're open bubbles, so we're going to use parentheses. Okay, so and the section that goes from 3 pi over 2 up to 5 pi over 2. Okay. Oh, I think there was one more piece, right? So union. Where was that last piece? Let's go see. The last piece was from here to here. Okay, that's an open bubble. So I'm going to use parentheses. Parentheses at, you have to peek right here, 7 pi over 2. Okay, so this is 7 pi over 2. And all the way up to, what is this? Oh, this is 4 pi. This is 4 pi. Okay, but 4 pi's closed, so he's going to get a bracket. Open bubbles give parentheses. I'm going to go write that down. The last section is parentheses. 7 pi over 2 up to 4 pi with brackets. Okay. Whenever they have the greater than or less than, that's a whole section of graph. Okay. All right, let's keep going. Let's take a look at a function. Okay. Let's take a look at the equation and do some stuff algebraically now. Okay, so considering this function, is the point 1 comma 1/2 on the graph? Let's see. 1 is the x value, and 1/2 is the y value. All right, so what I'm going to do is I'm going to put the number 1 in, and I'm going to see what I get. I'm going to do f of 1. So if I look at this equation right here, and I put 1 in for x, that's 1 plus 1. Down here, I'm going to plug in a 1 plus 2. I'm getting the point 2/3. Okay, so is that the output when you put 1 in? Oh, the answer is no. The answer is no. Okay, the question was, is this the point? The answer is no. The answer is no. All right, for the next one, okay, this one is a little different. It says if x is 2, what is f of x? Okay, so let's see. Let's put 2 into this equation. Let's put 2. I'm going to write f of 2, okay? Whenever you start putting a value into an equation, you have to tell people what you're doing. I'm putting 2 into the equation, okay? And what is the output? 2 plus 1, 3 over 4. 3 over 4, okay? What is f of x? Here it is, okay? So this is the output. They told me the input and said, can you calculate the output? Sure. Okay, now this question goes along with it, but they say what point is on the graph. All right, so this is function notation, right? This is function notation, and now they're just asking us for point. Okay, so the point was 2 went in and 3/4 came out. Okay, same information, just different way of saying it. Okay, letter C is a little different here. Okay, it says if f of x is equal to 2. Okay, what is x? So 2 is not the input. Okay, what is x? They want to know what is the input. They told us the output. They told us the f of x value. So when you're looking at this equation, okay, where does the 2 go? 2 is equal to f of x. It doesn't go in the x spot, it goes into the y spot. 2 is equal to x plus 1 over x plus 2. 2 is the output. You could put it on the other side as well, it doesn't matter. Okay. How are we going to solve for x? How are we going to solve for x? I know I'm going to put 2 over 1. When you have a fraction equal to a fraction, we are going to cross multiply. Cross multiply. 2 times this entire denominator. 2 has to get multiplied by both of those things, so that's going to make 2x plus 4. Okay, then you put an equal sign. Now we're going to cross the other way. All of this stuff times 1 just gives us stuff. After you cross multiply, there's no more denominators. There's left side, right side. Let's see, I'll subtract x from both sides. Subtract x, that gives me 1x. At the same time, I'm going to subtract 4, and I get negative 3. Okay, what is x? That's x. X equals negative 3. Okay, this question kind of goes along with that. Okay, what point is on the graph? Well, that's easy. I have the x value. I have the x value that I found, and they told me the y value. I'll just put them in point form. Okay, so look at the directions on the test to see what they want. Do they want to know what is x? You say x. They want to know point? You say point. what are the x-intercepts? Okay, to find an x-intercept, we let the y value equal 0. The y value equals 0. So when I'm looking at this equation, the y value is f of x. So 0 equals equation. Okay. Once again, we're going to cross multiply. Let's put a 1. Okay. When you cross multiply, okay, I'm going to put an equal sign. You get a left side, you get a right side. Okay, I'm going to cross this way first. This is so easy. What's 0 times stuff? 0. X plus 1 times a 1 is just x plus 1. Subtract 1, and I get x equals negative 1. Okay. Wait a minute. Is that how you write an x-intercept? No, when you have an x-intercept, remember, we have to write it in point form. So the x-intercept is negative 1, comma 0. Okay, make sure we write it as a point. What are the y-intercepts? What are the y-intercepts? Okay, to find a y-intercept, we are going to let the x value equal 0. The x value equals 0. Okay, so let's see. We have y equals 0 plus 1. 0 plus 2. Oh, that was easy. Okay, but remember, this is a point. Y-intercept, let's write it as a point. 0, comma 1/2. What is the domain? Domain. Okay, so algebraically looking at domains, we are going to look at the equation, okay, and we're going to look for radicals and we're going to look for denominators. Okay, looking at this expression, I see a denominator. Okay, so when I take a look at the denominator, the expression from a denominator cannot equal 0. So x cannot equal negative 2. Okay. Do you remember how to write this though for a domain? I can't equal negative 2, so what numbers can I use? That's right, all real numbers except you can't equal negative 2. So that means all other numbers can work. Okay, and now what they'd like us to do is to verify each of these features on this graph. So they graphed this rational function for us. Okay, and we're going to go through and see if all these things are true. Okay, so number 1 is the point 1, comma 1/2 on the graph. Let's go see. Where is the point? I'm going to use the same colors. Okay, so 1, comma 1/2. So if I go to the graph for 1, oh, nope, it's not a half. Do you see how it's higher than a half? It's more like 2/3. Okay, 1 gives us 2/3. All right, how about B? If 2 is the input, is 3/4 the output? So I'm looking for the point 2, comma 3/4. Let's see. 2, comma 3/4 is the output. Good. Okay. For letter C, they asked us what the x value was to give us a 2. Okay, we figured out that x should be negative 3. So does negative 3 take us to 2? Let's go see. Does negative 3 take us to a value of 2? Indeed it does, right there. Yep. Okay. Letter D. What are the x-intercepts? We only found one x-intercept. So I look along the x-axis, and it indeed only touches at one place, negative 1, comma 0. Nicely set in point form. Letter E. What are the y-intercepts? I think 0, comma positive 1/2 is the where it touched the y-axis. 0, comma, oh, there's 1/2. Yep. That's 1/2. And finally, what is the domain? Okay, so we figured out that there should be a graph everywhere except not at negative 2. Not at negative 2. So if you'd like to kind of take a piece of paper and look, is there a graph here? Yep, there's graph, there's graph, there's graph, there's graph. Uh-oh, what's happening here? Okay, it's going down, 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 okay? But it looks like it's getting asymptotic, so it's not touching, what value is this? Oh, it's not touching -2. Okay, that asymptote does continue up, 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 okay, and then the graph is over here. The graph is approaching, okay, but not using -2, okay? And there is graph everywhere. There's graph everywhere, except there's no graph touching -2. Okay, yep, everything's been verified. Awesome, okay? So doing things algebraically and graphically really should make a connection. Okay, one more graph. When you look at domain values, okay, domain values are the x values. We're looking at the x values. We're looking from left to right. Left to right. I notice here there's an arrow on this graph. Okay, there's an arrow, so it's going forever, forever. So in terms of domain, forever, forever, it's starting at -infinity. Okay, and the graph goes and goes and goes and goes. Oh, and then there's a break. Okay, so where does this break happen? 1, 2, 3, 4. This is -4, comma, -2. Okay, so there's no graph right here at -4. Since that's an open bubble, I will use parentheses. Okay, but then it picks up again. So union, -4, -4, and the graph keeps going and going and going until I get to this value right here, 5, 6, 7, 8, up to +8, and I will put what on the 8? Brackets or parentheses? A bracket. Okay, so remember for domain, okay, domain, you look left and right. You look along the x-axis. Where do we look for the range? For the range. Okay, so the range are the y values. The y values, okay, and you're going to look up and down the y-axis. Up and down the y-axis. So how low does this graph go? Okay, there's no graph down here. It seems like the lowest this graph goes is right here. Okay, and then what about the highest this graph goes? This is never going to get higher than that asymptote. Okay, so it seems like the highest is right there. So the lowest is -4. -4 with brackets because it touches. And all the way up to +4. Since it touches, we will use brackets. Intercepts. Let's look along the x and the y-axis. I see one right here, -6, 0. I see another one right here at 3, 0. And don't forget to look along the y-axis as well, 0, -3. Okay, make sure you write them in point form. How often does the line y equals 2 intersect the graph? Okay, y equals 2 is going to be a horizontal line. Horizontal line. Where's 2? It's right here, huh? Oh goodness, what is going on here? It touches 1 time, 2 times. Does it touch over here? Does it touch? Remember, a graph that approaches an asymptote will get closer and closer, but never touch. Okay, so we just have those 2 intersection points. It intersects twice. What does f of 3 equal? All right, so this is some function notation. Is 3 the input or the output? Okay, that's the input, and they want us to find the output. Okay, so let's go find the 3. Let's put x 1, 2, 3. Okay, oh, it's right there. Okay, that's the point 3, 0. So when 3 is the input, what's the y value? 0. Okay. Letter F is a little different, okay, because now it says for what value of A. They want us to find the A value. They want us to find A equals. They told us the output. the output, and they want us to find the input. Okay, so if you think about this as a point, the 4 is the y value. Now let's go see if we can find any points that have a y value of 4. 1, 2, 3, 4. So here's a y value of 4. The graph doesn't really get that high except for over here. Let's just check. What is this point? 5, 6, 1, 2, 3, 4. This is the point 6, 4. Oh, that's what I was looking for. I was looking for a point that had a y of 4. So that means that A must equal 6. And there's no other points that are that high, right? That have a y value of 4. Okay, down here, this is negative 4. Okay, so it's just that one place. All right, so for what values of A, when you have a question like this, okay, there may be more than one place. Just make sure you look all over, okay? Not when you're doing inputs. When you're doing inputs, there's one place. Tell me what the y value is. Okay, good to know. Letter G. Letter G, what does f of negative 4 mean? Okay, so this is the input. Okay, so I'm going to negative 4. Okay, and what is the output there? It's not negative 2. We've got to put a star by this one. This one's tricky. Okay, that point is open. There is no point there. That is not a point. That's an open piece of graph. Since there's no graph there, okay, there is no value. Right, so what we're going to say is no solution. Okay, and the reason is there is no point. There is no point there. Whenever you have an empty circle, an open bubble, you say no solution. Okay, and we're going to finish this one off with, for what values of x is f of x greater than 0? Okay, when you have a greater than sign like this above the x-axis, okay, so this means above the x-axis. Where is the function above the x-axis? I like to take out a little piece of paper and I like to totally cover up the graph that is below the x-axis. I don't even let my eye see that graph. Okay, so I'm looking for all of the places where it's above. Okay, so here's the graph above the x-axis. Oh, and here's another little piece of graph above the x-axis. Above, okay? It could say below, okay? And then we could do a problem where the graph is down here, okay? But it doesn't. This one says above. Can I equal the places where it touches the x-axis? No, it doesn't say I can equal 0. Okay, so then I'm going to put open bubbles right here just to help me write my answer. Okay, I can't touch the x-axis, only above. Okay, then we've got this arrow here, and we've got a solid point here. Okay, so it looks like I have 2 pieces, so I'm going to have 2 intervals for my answer. Okay, and we start from left all the way to the right. So this first piece, okay, does it stop at negative 10? Or does it stop at negative 11, negative 12? No, it's got an arrow. Okay, it goes forever. So starting at negative infinity. Okay, and what symbol are we going to put on infinities? Parentheses. Okay, and it goes all the way until x value, what is this here? Negative 6. And since it's open bubble, we'll put parentheses. Okay, union. Where does the next piece start? The next piece starts right here at 3 and goes all the way until 8. Okay. But what about the symbols? Open bubbles get parentheses and closed points get the brackets. Okay, hopefully, okay, can you get information off of a graph? Okay, and from an equation. Graphs and equations, right? Okay, but they go hand in hand. Good job.